Welcome everyone to this episode 21 on digital agriculture, driving digital transformation for food security. This webinar is being co-organized with the Food and Agriculture Organization of the United Nations, FAO, and the International Organization for Standardization, ISO. As you know, this webinar forms an integral part of the ongoing digital transformation webinar series. We're pleased to announce that this webinar will explore the concept of food security in the context of digital agriculture, along with the role of emerging technologies such as artificial intelligence, IoT, in delivering efficient interventions for the optimization of agricultural production processes. My colleagues will link the program for today's event in the chat. Please also include any questions that you have using the Zoom webinar chat function or using the question function. To kickstart today's webinar, without further delay, I would like to invite Anu-san, who is the Director of the Telecommunications Standardization Bureau at the International Telecommunication Union. Over to you, sir.
Hi, colleagues and friends. I'm Seizo Onoe. Thank you all very much for joining us. As we work to capitalize on new technologies in agriculture, ITU's priority is to ensure that the benefits of this progress reach everyone everywhere. We share this commitment with our co-organizers of this webinar, and the Food and Agriculture Organization, FAO, and the International Organization for Standardization, ISO. Together, ITU and FAO are operating a focus group on AI and the Internet of Things for digital agriculture. This group is open to all interested experts. It invites everyone to come together to develop a basis for a new ITU standards. ITU, ISO, and the International Electrotechnical Commission, IEC, are the world-leading developers of international standards. Our cooperation helps us to develop comprehensive standardization solutions that position everyone for success. Today's webinar is part of the series of ITU webinars on digital transformation. In this digital transformation of agriculture, we see a prime example of why the UN Sustainable Development Goals place such emphasis on partnerships. Digital transformation is creating convergence in business of different industries and associated convergence in responsibilities of different regulators. This is why inclusive initiatives are so important. Now, more than ever, we must work to build bridge between the different areas of expertise. Our focus groups and the webinars such as this one helps to clarify the contribution expected of all stakeholders, including the contribution expected of ITU. Our standardization process ensures that all participants' voices are heard. Every step toward is determined by consensus decision. I urge you to make your voice known. Working together, we can build consensus on how we want new technologies to impact agriculture and, most importantly, how we could best support meaningful steps forward in every part of the world. Thank you.
Thank you, Anu-san, for those insightful remarks. We will now move on to the next set of opening remarks, for which I would like to give the floor to Mr. Dejan Djekojevic, who is the CIO and Director of Digitalization and Informatic Division at the Food and Agriculture Organization, FAO. Over to you.
Thank you very much. Thank you also, Director Onoe and dear participants. Let me start by thanking our colleagues from ITU and ISO for co-organizing this webinar with the FAO. As we focus on digital agriculture and potential of digital towards food security and how we are supporting the digital transformation and its way forward, in a field where our organization have been engaging its expertise since several years now, and for tangible impact. This webinar series and our particular session today represent great opportunity to further focus on action, impact, and as we look at the power of technology, including artificial intelligence and Internet of Things. These technologies can be harnessed for the achievement of the Sustainable Development Goals, and specifically to agriculture and FAO's core mandate, the better production, better nutrition, better environment, and a better life for all, leaving no one behind. Today, in the challenging global context we are facing, and as we are proactively looking for new solutions, digital tools and processes have become indispensable for addressing world hunger. Achieving food security is an international priority, also encompassed by UN Sustainable Development Goal SDG 2. And it is clear that addressing this critical challenge is not something that any one country or organization can solve alone. So FAO stands very firmly committed to work in further partnerships, as we have here today, in the UN system and beyond, for the transformation to more efficient, inclusive, resilient, and sustainable agri-food systems for enhanced global food security. But more work still needs to be done. We can already see how conflicts and natural disaster have amplified basically the global food insecurity, which was already very negatively affected by climate change and 2 years of COVID-19 pandemic. To increase the security and resilience of global agri-food systems, a renewed focus on increasing sustainable productivity across existing farmlands is needed. And this is where digital technologies can help, and innovation in the agricultural sector applied across all the value chain is a key. Affordable access to digital technologies and digital public goods are paramount to unleashing the potential of agriculture and foster food security, in particular for rural and vulnerable communities. FAO has an essential role to play in promoting the use and adoption of digital technologies to facilitate the transformation of agri-food systems, as well as in advising and promoting a policy agenda and policy investments to massify the digital benefits of agriculture of the future. And this is where we also see a strong role of ITU and ISO in helping us achieve these goals. We are applying technology, innovation, and data as cross-cutting accelerators across all FAO's programmatic interventions to accelerate impact on the 4 betters and drive rural transformation. More specifically to our session today, artificial intelligence can have a tremendous positive impact, making agriculture more productive and sustainable. AI can benefit agriculture significantly across all regions and different farm structures. AI can be used to optimize agri-food systems and contribute to alleviating hunger. And FAO is already using AI applications to improve, for example, forest monitoring and combat crop pests in vulnerable countries. It can help farmers manage crops and livestock, detect pests and diseases, and optimize the use of labor, fertilizers, pesticides, feed, and water. On the other hand, the opportunities AI offers can also give rise to economic, social, and ethical challenges and risks. So we must make sure that AI tools are designed, developed, and used to be consistent with the universal human rights principles. So with this context in mind, I'm very much looking forward to our session today. So thank you again, and back over to you, Claire.
Thank you, Mr. Dejan, for those remarks, and also for the wonderful collaboration that we enjoy with the FAO on the focus group. So looking forward to more insights and more discussions on that. With that, now we'll proceed to the next set of opening remarks, for which I would like to pass the floor to Mr. Johannes Lehmann, who's the head of business development smart farming at the German Institute for Standardization. And he's also the ISO Strategic Advisory Group on Smart Farming convener. So please, over to you.
Thank you, and also welcome from my side, ladies and gentlemen. I will give the opening remarks as one of the co-conveners next to Andres Pereira of the ISO Strategy Advisory Group Smart Farming. Due to a mix of armed conflicts such as the civil war in Somalia, the climate crisis and COVID-19 pandemic, millions of people had already faced a huge price increase before the war in Ukraine. The war in Ukraine already strengthened those challenges, and the current World Hunger Index shows that around 828 million people had to face hunger in 2021. Particularly dramatic is the situation in some countries, for example, in Africa, as the Horn of Africa, and where the worst fruit in 4 decades, or in Somalia, here people in some regions are already experiencing life-threatening hunger. But what role does digital revolution of agriculture and food industry plays here? The use of modern information technologies such as AI and IoT is not for the sake of digitalization as an end, but as a mean to enhance and strengthen what the Food and Agriculture Organization of the United Nations calls the 4 key principles of food security, which are timing, access, use, and stability of food. And IoT and AI contribute to food security by supporting efficiency, quality, and stability. But it is important to look at food production holistically. All actors in agriculture and food value chain have to be involved, as challenges and potentials do not stop at the field boundary, nor do they start here. For example, issues such as data interoperability, cybersecurity, food loss, and waste have to be addressed in an interdisciplinary manner to achieve economy of scale and successfully apply modern solutions of these areas. And through international standardization organizations such as ITU and ISO, standards are developed that are needed for market penetration, adoption, and those scaling of modern information technologies. For this very reason, the work of ITU and ISO is central to the future success of data-driven agri-food systems and to supporting the 4 key principles of food security, which I mentioned above. Recognizing this need, ISO launched the Strategic Advisory Group on Smart Farming in September 2021, with more than 150 experts identifying the gaps and potentials in the current ISO standard landscape to realize interoperability across food value chain. Andres Ferreira will provide insights into this work in one of the keynotes. The ITU focus groups on artificial intelligence and Internet of Things for digital agriculture is ideal a complement as it aims to provide deep insights into the key technologies of AI and IoT. It therefore makes sense to cooperate even more closely in future and do everything possible to strengthen food safety through standards. And with this, I hand over to you, Mita.
Thank you, Mr. Johannes, for those remarks and also for highlighting the complementary activities that the focus group has, and looking forward to building on what we have already, building on the work that the focus group is doing. So for that, maybe we can move on to the core panel discussion for today's webinar, which is dedicated to digital transformation in agriculture. So to begin the panel, I would like to pass the floor to Dr. Sebastian Voss, who is the FGI for Aid co-chair. So over to you, Sebastian.
Thank you, Maitali. I'm very happy to be here with you today. So my name, as Maitali said already, is Sebastian Voss. I'm heading the Interactive and Cognitive Systems Group at FGI Fraunhofer in Germany. And I'm also one of the co-chairs of the SG20 focus group on AI and IoT for digital agriculture. And today I'm very happy that we were able to compile such a fascinating panel. We will start with a presentation by Abhay Parikh. I hope I pronounced the name correctly. This Abhay is with the 4th Industrial Revolution for Agriculture at the World Economic Forum. He has more than 20 years of experience of managing multi-stakeholder initiatives focused on agriculture and development finance. And currently, as I said, he's working as a lead for 4th Industrial Revolution for Agriculture at the World Economic Forum in India. And there he is responsible to drive the initiative to scale digital agriculture through public-private partnerships in coordination with governments, industry, farmer organizations, and startups. So without further ado, I would like to give the floor to you, Abhay. Please go ahead. I'm looking very much forward to your presentation.
Thank you so much, Sebastian, and good evening, good morning, good afternoon, everyone, from where the time zone you're coming from. As Sebastian also shared, just for introduction, I lead the agriculture initiative for World Economic Forum Center for Fourth Industrial Revolution here in India. Just to give you a brief on C4IR, as we call it, it's a center that's established to drive scale up and adoption of 4IR technologies, AI, IoT, blockchain, and drones in real economy sectors. And in India, we were established in 2018 when Honorable Prime Minister visited Davos and invited Forum to set up a center here in Mumbai. The center here works on the theme of solve for India, solve for the world. So whatever we are doing here in India aims to create a toolkit or a model that can be replicated across other countries who are facing similar challenges. So within India, we are working on different sectors, including agriculture, health, mobility, drones, and others. And I'll just focus my discussion today on agriculture and what we're trying to do there. So I'm coming more from a policy perspective on how we can see a multi-stakeholder collaboration or a public-private partnership that can be created to scale 4IR technologies within the agriculture sector. It's very apt for India also because India, as you know, it's an emerging economy, and at the same time, India agriculture sector is pressured to deliver and to produce for 1.3 billion people with the entire challenges around climate change and other geopolitical situation, and that too in a situation where there are more than 100 million smallholder farmers with less than 2 acres of farms. So it's very important that more efficiency is brought in, or more sustainability is brought into the sector, and it is transformed into a more agile and a data-driven system. And in this thought process, in this context, we started our work. How we structure our work on scaling 4IR technologies in the agriculture sector is see how these technologies can impact 3 critical areas. First being the inclusivity. So how we can enable more women farmers and youth and smallholder farmers access financial services through digital means, both credit and insurance. Second big impact area that we focus through digital technologies is sustainability. How do you ensure that the farming operations are sustainable? That to focus on optimal utilization of resources like water, inputs. And third pillar or third impact area that we focus on is efficiency, bringing the efficiency in the supply chains, post-harvest value chains through technologies. So these are the 3 impact areas that we try to focus on, and how we started our work is to create a library of 30 odd use cases where 4IR technologies, AI, IoT, blockchain, drones can actually create an impact on the agriculture sector. Now, when we started moving to our work, and I'm just sharing it more as a story, we realized that for these technologies to scale in agriculture sector, though India has more than 1,000 plus agri-tech startups, they've still not scaled to the level they could have, or the market potential is. And then we realized there are key 4 challenges that needs to be addressed at the ecosystem level for these technologies to scale. The first being the data. All these innovators or startups who are working with an AI-based solution or a 4IR solution need data. And for that, they all are putting in their resources and collecting the data sets from the ground, where we understand government already have good data sets, of course, sitting in silos, and their quality and their availability has to be understood. But there is a possibility that government data sets can be enabled for private sector and help reduce their operational expenses, but at the same time, scale the entire adoption of 4IR technology, scale the innovation base. The second big challenge that we identified was for these technologies to go on the ground and serve each and individual farmer is a very high cost affair, especially in a country like India. They need resources, they need foot on ground at the end of the day. And can governments come in and help these technology providers or these solution providers through their own existing resources? And third area that we realized that needs support is validation of the technologies. So we understand that many of these technologies are coming from great tech players, but many times they may miss out the domain knowledge of agriculture. So how we can bring academia and technology providers or the industry together and create a sandbox for agri advisories. And lastly, looking for more convergence areas or policy formulation areas that can help for AI technologies to scale. Now, bringing all these challenges together, we started developing a PPP framework, or a public-private partnership framework for digital agriculture. And as I said, it focused again on governments being the anchor partner or the drivers of an enabling environment, where they bring in all set of financial and non-financial incentives for a private sector innovator to come and deploy and scale their solution in a particular geography. That's where we came up with this PPP framework, which again focuses on 4 key areas. One, data. So how do you enable data sets for private sector? So we come up with the concept of agri data exchange and an agri data management policy to give a policy framework on data exchange. This data exchange is conceptualized as a thin layer between data providers and a data consumer, and a transaction layer or a middleware between these two. So we are already in the process of piloting it in one of these states in India. It's called Telangana, and that's where we're trying to see edX. The government of Telangana has adopted the framework and trying to see if edX can be implemented there. The second big pillar that we are focusing on is government enabling front-end resources. So in India, if you may, just to give you an introduction, there are last mile resources of self-help groups, cooperatives, farmer producer organization, primary agriculture cooperative society. So all these last mile institutions have been serving farmers for ages. They've gained the trust of farmers and they are supported by governments. So our focus is if these institutions can also become last mile channels to deliver digital tech services, but also to inform and make farmers aware about these services to better adopt and actively use these services. The third pillar of this PPP framework is the sandbox. So we are in the process of establishing first agri sandbox again in the state of Telangana, which is our first focus state where we are working in India. The sandbox basically aims to provide a safe environment for agri advisories to be tested and improvised and ready to be scaled on the ground with farmers. Because a big challenge that we see if agri advisories fail, the last impact or the loss would be on the farmers. And so how do you safeguard farmers while encouraging innovations is what we're trying to do through this agri advisory sandbox. Just to give you an example on how we've implemented this on the ground with the government is in Telangana again, where we have kept chili as the focus value chain. We've identified 4 use cases of AI-based advisories, AI-based quality testing, soil testing, and finally a market connect platform. These all 4 solutions have come together in a consortium partnered with the government of Telangana, and they are delivering these services around this time to around 7,000 chili farmers on the ground. And now we're trying to understand the impact on how farmers are adopting these services and what efficiencies or improvement in their farming practices that we can document. So this is how we're trying to create our entire framework. We are working on the ground with state governments in India or the province governments to generate these learnings from the pilots. We're taking these learnings at the highest policy level with the Ministry of Agriculture of India also, and try to see and bring these learnings to them while they are also creating an agri-stack to showcase that how different technologies can be or how different partners can come together to create an ecosystem where these technologies can evolve, where all the value proposition for each and every partner is met, and governments are creating an enabling ecosystem. Not more focused on financial, but more focused on an infrastructure ecosystem or a policy ecosystem that help these technologies to evolve. So I'll stop my presentation or discussion here. Yeah, I'm happy to answer any questions that you may have.
Thank you very much for this perspective. I think it's very interesting to see how such frameworks and sandboxes can lead to the way forward to the digitalization of agriculture. So what I missed to say is that we will have a discussion after the presentation. So I guess we have some questions and comments, so please keep them in mind. We will continue now at first with the presentation of Andres Ferreira, who is data asset manager for Syngenta's global digital agriculture team. And his responsibilities in Syngenta include leading the development of Syngenta's global machine data integration platform, its analytic platform, and the semantic infrastructure that supports both of them. He seeks to make field operations and observations data findable, accessible, and operable and reusable, the so-called FAIR framework, within the context of the data ethical process. His ultimate goal is to help growers, large and small, to maximize the profitability, sustainability, and the freedom to operate their agricultural operations. Andres, I'm happy to have you. Please go ahead.
Thank you. Can you see my screen?
Yes.
All right. So thanks everyone for the opportunity to share some material with you. So I'll be elaborating a little bit on what Johannes mentioned earlier about the ISO Strategic Advisory Group for Smart Farming. So first, let me quickly define what we consider to be smart farming in that group. And it's essentially a data-driven process of principled decision-making in agricultural value chains that occurs as the optimization of multiple, often conflicting objectives in the context of global volatility, uncertainty, complexity, and ambiguity, right? And those ideas that were mentioned earlier of profitability, of sustainability, of compliance, are part of those objectives, right? And the agricultural value chains are multiple, and the causes or manifestations of that volatility, uncertainty, complexity, and ambiguity, which have also been mentioned before, are also many. So if we start looking at how farming works, contemporary farming works, you'll see that there is a increasingly large number of actors that are exchanging data. I'd like to echo the theme of data that was brought up by the previous speaker. Large amounts of data being exchanged, and as the complexity of the system grows, the problems that come trying to exchange the data and keep it usable by the different parties, it just grow. There's terrible interoperability problems in the industry. So ISO, understanding that standardization would be an important part of a solution here for those interoperability issues, chartered that a strategic advisory group for smart farming. And its primary deliverable is a standardization roadmap. And that roadmap is meant to provide ISO with a strategic framework for moving forward in the space. Just a quick note, there were about 188 experts participating in this, covering different aspects of farming, going from crop production, animal products, urban farming, and different aspects of that as well. So let's jump right in to the summary of what we found. So first, reiterating the idea that smart farming is very challenging. It's a multi-partner data exchange process, and it's increasingly necessary to exchange data, but very difficult. So lining up the input data at scale for data-driven decision-making is also very difficult. And also echoing something that was said earlier, models to assist in decision-making and the tooling for that are often poorly documented and poorly validated. It's easy to get the right answer for the wrong reason on any given year, and then get the wrong answer the following year. And standards and standards implementation can make a huge difference in this. But standards are very well kept secrets in the industry. They're not taught in the university. So when professionals come out into the marketplace, they're not aware that there's standards for various things. And not only that, but we don't promote them very well. as standards organizations. So agricultural technology providers are constantly reinventing the wheel. And then when they try to use a standard, when they do find out that something exists, just conformity assessment, that knowing that they're doing it properly, is typically difficult and expensive. So that was the first theme. Second one is that the standards community is going to just have to do it better, right? So we have an increasing number of actors in the smart farming data standards space, right? It's recognized as a hot topic, so we have multiple organizations, not just ITU and ISO in this space, right? And these organizations also have multiple groups within them, technical committees or what have you, that are sometimes unaware of the work that one another is doing. So we need to leverage that diversity so it can become part of the solution and not part of the problem that we're describing of a lack of common standards. So the Strategic Advisory Group made some recommendations along those lines. First, that we need to look internally within our organizations, look for gaps and blind spots and coordinate among our different internal groups so that they can act in a coordinated fashion. Then we have a lot of external collaboration to do. We should collaborate on a global landscape so it's clear who has done what standards already exist so that we don't have overlaps. And along with that, coordinate our roadmaps so that when somebody's tackling some new work, the rest are aware. And we need to emphasize interoperability among standards. Having a standard for some aspect of an agri-food system isn't enough if that standard can't readily interoperate with other parts of the system, right? And perhaps most important, we need to communicate with the users. We need to enable them. Third thing that we found is that the domain is bigger than smart farming. So we started with that smart farming mandate, but something important is that you need to learn to walk before you learn to fly. There's a lot of things that producers need to do that don't necessarily qualify as smart farming, but that we want to enable as necessary conditions to get to the point of smart farming. One of them is being able to calculate profits and losses at a field level, being able to calculate the active ingredient loads, help people stay compliant with the labels of their products and so forth. That's really important for a producer. So we need to work to put standards in place to help users do this, and so that we can enable that data-driven decision-making. Standardizing reference data like a data model and lists of crops and other reference data and the semantic infrastructure to deliver it is also a very good example of those sorts of things. Also, on-farm activities don't happen in a vacuum. In pursuit of greater sustainability, there's an increased emphasis on mixed crop livestock systems, for example, and optimizing supply chain and field operations interactions, right? So for that reason, we sort of renamed our effort along the way from smart farming to one of data-driven agri-food systems that include smart farming. And I have made these slides available. So hopefully you can check on them later, look at the main recommendations here, and reach out to us if you have any questions. And finally, since we were talking about AI just before this session, I asked ChatGPT to give me a haiku that would be relevant for the current state of standards, data standards in agriculture. And this is what I got. Battered by the storm, persistent spirit endures, sunshine is on the way. Thank you.
Thank you very much for this presentation. Very interesting to see the activity of the ISO SAG summarized so nicely. So our next speaker will be Claudia Rostler. Claudia is the director at Microsoft Cloud for Industry and responsible for strategic partnerships in food and agriculture. And she helps to helps organization with their digital transformation and enables them to build data-enabled analytics and science solutions for the food, fiber, and fuel value chain. Claudia, the stage is yours. Very happy to have you.
Thank you, Sebastian. First, let me say thank you. I'm truly honored to be in this group of expert speakers, and also very pleased to see the common themes around the convergence of industry, the multi-stakeholder collaboration and data. That's really near and dear to my heart. In my role gives me the opportunity to work with stakeholders across the value chain, from the traditional input providers, OEMs, to insurances, banks, brand companies, and also the government entities that all really have an interest and see the urgency for digital transformation in agriculture. So my previous speakers laid out really nicely what's driving this need in terms of climatical changes, geopolitical changes, economical challenges in the industry, and really what we see as the opportunity of digital transformation is this promise of data and advanced analytics. And this is to make more timely, more precise, and more granular decisions on farms. So this includes being able to predict and prevent hazardous events that may have an impact on yield or that may have an impact on the environment. This requires to be able to monitor and model different variables and data that's coming from farms, like soil data, weather, imagery, and it's really the prerequisite for farmers to be able to participate in precision farming and also understand the impact of more sustainable practices. But in order to do so, we really need to understand what's happening on farms and what's sort of the cause and impact, like Andre's statement about making wrong predictions based on the quality of data that's coming in. So advanced analytics really requires this high quality of data. And this means it's the right quantity of data, it's the quality and the granularity of the data, because ideally you want to be able to get down on a 10 by 10 centimeter prediction, or on a plant-based prediction on the farm. And no matter if this is for precision farming, for precision spraying, for variable rate seeding, or for accurately predicting the yield on a farm, all of this really requires this high value of data. So I often get asked, what is the most important technology? And I think what came across also in the previous conversations, it really depends if you're a smallholder farmer in India, or if you have a fish farm in Norway, if you're a grain farmer in Eastern Washington, or a dairy farmer in New Zealand. What is in common is sort of this opportunity, like using IoT for a 24/7 observation of a bin, of a farm, of an animal, which is really hard for humans to comprehend and to cover, and sort of this constant understanding when a potential risk comes up on a field, like a pest risk, or there is an alert in a barn. So that's a real value in itself. But then on the other hand, you really want to just go beyond using one data source and take advantage of artificial intelligence and machine learning to truly be able to combine different data inputs and understand the cause and impact on a farm or a barn. So what's important to understand is that technology such as AI has an advantage over our human ability to really reason over, if needed, hundreds of different inputs. Whereas as humans, we may look at different information, but we ultimately make decisions based on two options. And like Andres also said, there's also a big risk to just trust on AI. So it's this combination of using AI and human understanding to truly take full advantage of technology. But today, what we're seeing is that when you look across the industry, predominantly most of the digital tools and technology that is out there is based on one data input. There's really limited insight that's coming from this separate data. And the reason for that has been mentioned before. It's on one hand, the lack of data standards, the ability to reason over, let's say, for example, different equipment that's running over the over farms. It's the different resolution and the different availability of information like satellite sensors, drones, and sensors that are on the ground. And all of this is coming in different spatial and temporal versions. And it's really difficult today to overlay those different data and reason over them. There's also an issue that a lot of the insight today is really coming from one farm, and there is this notion that digital innovation needs to be paid for by farmers. So as everyone who is in the data and analytics space understands, it really requires to be able to reason over more amount of land to see the common patterns, being able to compare. So we truly see the need that we shift the business models and the way how digital transformation is done in the agriculture space and find more players that help to aggregate and help to reason over multiple data. There's today very little what we call digital feedback loops in the industry. So this means if you are making a prediction, if you are making a decision on the farm, it's also important to be able to track what decision you made and what you have applied. So ultimately you get a complete digital feedback loop and you can create learning. So again, this and improve in the future. This really requires to have a consistent digital feedback loop that's barely existing in the market today. And then we also see the issues of farmers providing their data to some of those companies that can help with this aggregation and can help with running analytics over more aggregated data. So we need to be able to address the needs of data security and data trust. And then lastly, there's truly also very limited trust in some of the data models that are used today because they are made or based on very limited data input. So in order to, when you think about the things like the notion of developing carbon markets, the trust in being able to monitor, but also efficiently and correct calculate carbon sequestration on farms is a prerequisite for those new opportunities to come up and be able to be explored. Now, there's really 5 things I want to close with that we believe are important to drive a change in the industry. That's number 1, the elimination of those data challenges, the data silos is those are needed to get stronger insight, being able to predict. We really want to make sure that the industry, the digital transformation needs to come not from the farmers alone, but there is a whole bunch of new industry digital business models coming up that are enabling farmers to participate and also being able to take advantage of data and insight that's coming. We definitely see a lot of duplicative work in the industry that is actually even making this notion of having different data standards worse. Just imagine 10 input providers and 10 OEMs wanting to exchange data, likely can end up having 100 different data standards. So we want to help to avoid this duplicative work and also build a foundation for companies to work together and collaborate. This should help with the interoperability in the industry and the incentive to really collaborate and work together as an industry. And then lastly, we see the importance to ensure the data privacy and the data security that really is required for growers to trust in data and analytics and see the advantage. While we all voluntarily share data on a day-to-day basis, we see quite some resistance on the agriculture industry today. And I think this is going to change once participants can benefit from taking advantage of the data and analytics. So Sebastian, back to you.
Thank you, Claudia. Thank you very much. I think this was a very nice presentation, and it nicely fits into the other talks as well in at least two aspects. And this is something I hope we have time to tackle both of them, but this is something that there are two questions I would like to ask all of you. And this is when it comes to something that especially Claudia touched upon, which is data quality. And data quality, I guess, also includes the label quality. Because if we want to do AI, then we need to train our models, and for most models, we need a significant amount of labels as well, and those labels need to be sufficiently correct to avoid label noise. So I would like to ask you on this take on this, Claudia. I would like to start with you. So maybe you could give us a quick insight in how you think about labels, and then maybe Andres, maybe you could tell us a little how you think about the importance of standards for data labels and the quality of labels. And then maybe Abhay, maybe you could share with us something from your expertise within this framework that you are thinking, if there is a way forward to actually gather labels from ag experts.
Yeah, I can probably start quickly. I think there's really three things that jump to mind when it comes to labeling. One is the use of reference data sets to be able to understand and also translate, if this makes sense, data that I'm seeing and being able to compare. It's almost like used like a dictionary to be able to help with labeling. The second opportunity in labeling is to the use of synthetic data to have a more structured way to train data and label data in a more of a lab setting and a dry lab setting. And then lastly, I think is really the opportunity to use other data sets to detect errors in labeling and understand sort of where things need to be corrected and manually. Those are all three different techniques that I believe are going to significantly help in the data on the data quality side. But love to hear the experts here as well.
So I have two thoughts that come up. One, generalizing this, the agriculture involves collecting a huge number of data variables, different forms of data that we want to use as inputs to decision making, and the meaning of the data tends to get lost rather quickly, right? So one of the things that I believe is important is to standardize data type definitions in general, say, air temperature or yield in mass per unit area, so forth, and make machine readable data type definitions available as a digital public good, set up part of that semantic infrastructure so it becomes easy for people to produce and consume standardized data. That's one thing, and it's one of the recommendations of the ISO Strategic Advisory Group. The other thing about data quality is that your data is only as good as the maintenance of the equipment and the attention being paid by the collector of the data and so forth, right? And for that, we need to think creatively about the incentive structure for farm operators and producers in general to understand the value of good quality data and make it easy for them to ensure it, right? Something as simple as a weather station. It's incredibly challenging to maintain a high quality weather station network at scale. That's what I have. Thank you.
Yeah, so coming from our experience, and pardon me, I'm not the data expert, but at least from the perspective of the data AI-based infrastructure and the technologies, what we realized is there are 15 to 20 data sets that in the permutation and combinations are used by most of the tech providers or the tech developers. And one of the key things that we also, and I agree to Andreas, is the standardization of these data sets to the granularity, right? For example, again, soil data. So if you say soil data, you need soil data of which region what is the precedence or the history of that data. You need it at a village level or a farm level. So all these data sets, if has to be shared by, say, a government, that standardization is really important for the government to understand how they should create or collect data and share with the private sector. So from our learning, a big gap that we see is that the governments have been collecting data, they still don't understand how private sector would like to use it. What are the standards that they want it in? What are the formats that they want it in? And what is the end outcome that they're expecting from these data sets? So creating that convergence, I think, is really important when you're talking about data sets and labeling them.
Thank you so much. We are a little behind time, but I would like to take the chance that I have you here with me for one last question. And this is going towards all of you as well. So one thing that I'm specifically interested in is the question of how collaboration between human and machines can be established. And this is something that Claudia also touched upon in one sentence at least. So is this something that you see as a reasonable way forward, like in a truly interactive collaboration between human and machines? And then is there something that you know from your work on standards, Andre, that's sort of related or relevant here? And then if we think about the actual user, is this something that would be accepted by the user, or is the user maybe more interested in some sort of autonomous agriculture Terminator robot or something?
So I'll take that first. I think that augmenting a producer's ability to interact with their environment is a very good idea. The availability, especially of agronomic expertise, is spotty in our world, right? If you go to some geographies, yes, you have readily available extension agents that are willing to help the producer understand what's going on and come up with an optimal course of action. But there are a lot of places where there aren't so many agronomists, and so we need to introduce technology as a way of enabling the agronomists and crop advisors that are available to reach more hectares, right? And also there's labor shortages in some geographies, so those people are very interested in autonomous operation as well. So here there's what you would typically have though is a lot of concern on the part of regulators about things like safety, right? And that's where standards can come in. ISO, for example, has some excellent safety frameworks for robotics. For example, Technical Committee 299 on robotics has a framework for handling safety in robots, right? And there's extensive work also on autonomous on-road vehicles that can be harnessed to deal with autonomy off-road. So I think there's already a lot of work that's been done, but I'm going to go back to what I said earlier. These are wonderfully kept secrets, right? Decision makers and professionals out in the field aren't aware of these things, right? In part because experts go, they do their job, and then they retreat, and the organizations don't have enough resources to go out and promote this properly.
Thank you, Andres. Claudia, do you have a view on that as well?
Yeah, I mean, I just echo what Andres said, but I also mentioned in the beginning, I mean, we haven't even talked about the labor shortage on farms. We haven't talked about aging workforce in some of the regions. So also what Andres brought up about robotics, I think it's important to use technology as an enabler of humans. And like I said previously, IoT, fantastic, being available 24/7, AI, fantastic for being able to see things easier. Thanks for the call out, ChatGPT, like for being able to reason over massive amounts of data that's really difficult for a human brain to do. And then the likes of automation, robotics to enhance like human capabilities. So I think it's really important to use the technology in a way that it's enabling humans for making better decisions, be more productive, and then it's hopefully used in the best way.
Thank you. Abhay, do you have a view on this as well? When you in my eyes, you have this very user-centric approach here, so maybe you could share something from that perspective as well.
Yeah, so of course, I think, and I'm coming again from the experience that we have in the ground. I would call it more of a phygital model that's coming through. The technology is there and supporting farmers, but at the end of the day, there's someone who's helping farmer to understand the technology and adopt it. So I think having that cadre of last mile people who will educate farmers to shorten their learning curves is really important. And as Claudia rightly mentioned, the technology should be an enabler of efficiency or sustainability in the farming operations. But it's important to handhold farmers to do it that level where they trust the technology, start using it, and actively you start using it. I think that bridge we have to keep in focus.
Thank you. I would like to continue discussing with you, but unfortunately the time is running fast. I hope that we will find another opportunity to continue this. One might just be the focus group on AI and IoT for digital agriculture. So I think that your expertise would be very valuable there. So the next meeting will be end of May, I think 22nd to 24th. And I would be very happy to see you there as well, continuing on this discussion. And if it's in present, and maybe also during a coffee break. But that's only the near future for today. I'm very unfortunate actually to close the session, but this is what I have to do now. Thank you again. Thanks to all the speakers. It was a very, very fascinating panel and very nice and interesting presentations. And also, I would like to thank you very much for all the insights that you shared during the discussion. I would like to thank the ITU for the preparations, especially Maitali, and also the audience for your interest here. And with this, I close the session and hand over to Rami, who is not only my colleague as a co-chair of the focus group, but also the person who will give the closing remarks. Have a nice day.
Thank you very much, Sebastian, and very happy to see you and to see all the colleagues in this very, very extremely interesting session. So my name is Rami Ahmed Fathi. I'm the sector head of the strategic planning sector at the Egyptian Telecom Regulatory Authority, the NTRA. I'm also the chair of the regional group Africa of Study Group 20 and co-chair of the ITU FAO focus group AI4A. As you probably know, Study Group 20 is the lead study group responsible for developing standards related to Internet of Things and smart cities. And within our context, it is the parent group of the AI4A. Of course, the whole purpose, as Sebastian slightly mentioned, the whole purpose of the focus group is to develop research and pre-standards activities. Ultimately, our goal is to work hand in hand with our partners, the FAO, in developing recommendations for the industry, and in particular in developing use cases and in developing relevant solutions, for, of course, by means of developing standards that would be applicable for the industry in order to promote and develop the digital agriculture sector. First, I would like to thank all the distinguished panelists and participants for joining episode 21, the digital agriculture driving digital transformation for food security. And as you probably know, this webinar is part of the ongoing ITU digital webinar series. I would like to take also the opportunity to thank the International Organization for Standards, the ISO, and the Food and Agriculture Organization of the United Nations, the FAO, for co-organizing this carefully curated webinar with us. What we have learned from today's discussions is that global food production will need to be accelerated to meet the demands of the growing global populations, which is expected to reach 9.7 billion by 2050. And we all know technologies such as AI, Internet of Things, UAV, soil sensors, and harvesting robots can play a vital role in enhancing agricultural production processes. And this is to ensure that we meet the rising global food demand. And that, of course, needs to be in line with satisfying or realizing the SDGs. Standards, stakeholder engagement, and partnerships, from all we learned today, are all crucial critical success factors to deliver the promised enhancements of digital agriculture. With key representatives from the World Economic Forum, Syngenta, and Microsoft Cloud, who presented today, we hope to channel some of these use cases on our focus group AI4A deliverables. The next meeting, as Sebastian told us, will be held in May. We invite you all to attend this meeting. More details will be, of course, circulated via the mailing list, and the Secretariat will provide you with details in the chat on how to subscribe. I once again thank you all for your kind attention. Please do stay tuned with us for more episodes of the Digital Transformation webinar. Thank you very much. Back to you, Maitali.
Thank you, Dr. Rami, for the excellent remarks and for really wrapping up what the discussion encompassed. We will now have remarks from Dr. Bilal Jamousi, who's the chief of the ITUT Study Group Department. So may I ask my colleagues to roll their closing remarks from Dr. Jamousi, please. Thank you.
21 on digital agriculture driving digital transformation for food security. I would also like to take this opportunity to thank FAO and ISO for co-organizing this webinar with us. According to the FAO report on the state of food security and nutrition in the world 2022, nearly 828 million people were impacted by hunger in 2021. Additionally, it is estimated that by 2050, the world will need to feed approximately 10 billion people, thereby requiring nearly 50% more food than we did in 2010. The adoption of digital technologies for agriculture is revolutionizing food production cycles with the aim of improving agricultural yield and limiting the use of fertilizers in accordance with the Sustainable Development Goal 3 on reducing global hunger. Furthermore, we are now also looking into how these digital technologies can curb food loss and reduce food waste in alignment with Sustainable Development Goal 12. In this context, technologies such as blockchain and RFID tags can pave the way for smart packaging to track information related to food products and pinpoint potential contamination during the manufacturing process. Other technologies such as unmanned aerial vehicles, UAVs, can play a pivotal role in agricultural applications by supporting visual inspections for plant health monitoring and pest detection. On the other hand, during the harvesting phase, robots can be leveraged to conduct the harvesting with more accuracy and at a faster pace with the aim of reducing crop wastage. Technologies such as AI can also be incorporated across agricultural production processes to enable predictive analysis to assess soil quality, type of crop, the right time to sow the crop, and estimate yield predictions. To further explore the benefits of these frontier technologies in agricultural domain, ITU joined with FAO to establish the focus group on artificial intelligence, AI, and the Internet of Things for digital agriculture. Since its establishment, this focus group has been serving as the global platform for driving discussions on digital agriculture. Today, we are privileged to have distinguished panelists with us from the World Economic Forum, Syngenta, and Microsoft for this webinar. I would like to thank you for your insights on how digital transformation in the agricultural sector can help us tackle the issue of global hunger and ensure food security. I would also like to thank the co-chairs of the focus group for leading this pioneering group, which couples traditional agricultural knowledge together with the field of emerging technologies. The focus group on AI and IoT for agriculture is open to all interested stakeholders, and I would like to invite you to join the discussion, which will lay the foundation for international standards on this topic. With that being said, I look forward to meeting all of you the next meeting of the focus group. Please also stay tuned with us for more episodes of the Digital Transformation webinar series. Thank you all for your attention.